Hi, everyone, and welcome to another series of Foundry virtual events. My name is Joyce, and I'm your marketing host for today. I'm here with my colleagues from the creative services team here at Foundry. So I'm here with Martin Meyer, head of creative services here in EMEA. We've got Terry Riasat, head of creative services here in America. Jesse Burgess, creative specialist here at Foundry, and also DJ Matthias, also creative specialist here at Foundry as well. So I'm super excited to be here with our team, talking a little bit more about Nuke and episodic animation. Before we dive into the session directly, I just wanted to share a couple of updates here what we have at Foundry. We have over 40 webinars here on demand. For any information on those or to find them, you can go onto our foundry.com/events page. You will also find new listings there as well. For any questions, any feedback, if you want to participate in any of our virtual events for next year, please send us an email on virtual.events@foundry.com. So speaking of upcoming schedule, we've got quite a busy November coming up. So we've got a Modo webinar coming up on November 17th. We've got a webinar with Pedro Andrade from Complayer, if you're familiar with that, talking a little bit about more of his compositing program, the Next Level program. We're also going to be having a Smart Vector webinar as well on November 24th, and also an introduction to practical compositing with Austin Myers as well, which will be held in December. So make sure you tune into those, and you can register by visiting our events page. And for those of you who don't know, Nuke has won an Engineering Emmys Award. So just wanted to raise awareness of that. And also congratulations to all the nominees who've also won an Emmy as well. So congratulations on that. And I just wanted to say that we won the Emmys, so very exciting. So we've got a lot of content available on our Foundry Learns page. We've got documentation, we've got release notes, we've got documents for developers as well. So make sure you check out our Learns page. It should be on foundry.com/learn. Stay up to date with us by following us on our social media channels. We also have an Insights Hub where we host a lot of articles and spotlights as well on a specific artist. We've recently done one with Victor Perez as well, which is super interesting. So you can find those in our Insights Hubs page as well on Foundry. We recently did a really amazing collaboration as well with Austin Myers, who's put together some really cool Nuke tutorials. You can again find those all in our learning material on our learning page as well. So this is live now, so you should be able to find all of this on our website. We also have we recently done a webinar with Josh Parks as well on what I wish I knew in Nuke. So he also does some training materials. He does some one-to-one trainings as well, some coaching. He also provides some compositing materials as well, some templates that you can use to play with. For more information on those, or if you wanted more details on his one-to-one training, you can go onto compositingpro.com. So for any students out here, we do provide free student licenses. So you can explore all of the Foundry Creative software through the first year free program, which is an opportunity for new students to experiment with Foundry products for 1 year and free of charge as well. So we have Nuke Studio, Mari, Katana, and Modo that you can try out for a year. Lastly, I just want to say a massive thank you to all of our speakers, studios who have so far participated with us. Thank you so much for joining us. Thank you for sharing your projects and your experiences throughout 2020. It's been a crazy year for all of us. So thank you for joining, and I'm really looking forward to building up the stories even more next year. That's it from me. Thank you for joining again. I'm going to hand over to Terry, who's going to talk a little bit more about this webinar, and then we'll dive straight into the session. Thank you.
Thanks, Joyce. So as we're about to move in and start up to it, just want to give a quick reminder, if you have any questions beside your chat, there is the tab that has questions inside of there. So we'll be able to actually answer all the questions rather than getting lost in the chat. So we're joined by all the creative service specialists that help make this webinar. So I think we're going to just jump into it right now. Hi, everybody. Welcome to this Foundry Skill Up on Nuke for episodic animation. Thank you for joining. Today, we'll be looking at some powerful ways that you can be using Nuke to add to existing workflows that you might be using, or if you're new to Nuke and you want to jump into some workflows to streamline the process. We're going to focus on 4 specific topics that can be utilized to power up your animation workflow. First up, Martin Meyer will be exploring a custom pipeline tool he's built to navigate multiple shows, sequences, and episodes, complete with auto-loading of templates and assets. After that, Jesse Burgess will be showing us how live groups can be used in day-to-day production. More and more studios are adopting this workflow, so it's a great opportunity to see different cases for the live groups, covering it as a shared tool all the way through to a master comp workflow. After that, DJ Matthias will take a look at a Nuke script that requires revisions and will traverse the node graph to address these changes. He'll also cover some of the core concepts on how to use animation tools in Nuke and how to quickly make any timing changes. Finally, Terry Ryasat, it's myself, will cover some workflows using the 3D space in Nuke alongside geometry from the 3D department. We'll have a look at various examples. We'll look at the access node to see how we can add elements that are going to match our render. We're going to take a look at building texture using the UDIM importing. We'll also look at relighting and projections. There's a nice variety of topics that we will cover to have something for everyone that can be used in your episodic production. And finally, a big thanks to Ari Rubenstein, as we'll be using some elements from his short, The Blues Crab. I encourage you to check out the final piece on Vimeo, as for this webinar, we'll be working with the unfinished comps, so be sure to check it out. Thanks, Ari. With that, let's go ahead and get started with Martin. He is going to show us through Nuke's customizability how he can automate the animation pipeline management. This will allow the teams to maintain consistency, not have to dig through file structures to find assets for the shots or the latest versions of the comp. Python itself will allow you to automate any repetitive task, and Python runs through the heart of Nuke. So let's take a look at what Martin has cooked up.
Hello everyone. This is Martin Meyer from the Foundry, and welcome to today's webinar. So before we move to the actual assembly of the shots and management of the internal structures of the individual shots, I would like to show you a tool that we developed that allows you to organize the work, manage the versions of the shots, the locations of the shots, and also where the renders will be going, to essentially minimize any kind of human error as the complexity and number of the shots grows within your pipeline. To build up the user interface and the functionality, we will be using Python that ships inside of Nuke, and it's governed by the VFX reference platform. And for the user interface, to create some interesting and useful user-facing experience for our tool, we'll be using Qt for Python that ships with Nuke as well. If you're looking for more information about Python or Qt, or just general use of Python APIs inside of Nuke, you can always refer the help files, which are very well documented, and they provide you some useful examples. So to use our tool, we need to tell Nuke where it can find it, and that it should use it when it's starting up. This can be done quite easily. All you have to do is find the locations where your .nuke folder resides, and in there are the Nuke preferences that define how each session will be initialized. So once you located the .nuke folder, you can go ahead and open up the init file in the editor of your choice and edit the paths to your plugins. So in my case, I saved the tool into this location that I'm highlighting right now. And all you have to do is just copy paste the path to the plugin itself, and then go ahead and save file. Once the file is saved and you relaunch Nuke, you'll have a new item on your upper part of the user interface, and also in the toolbar you will have the ability to launch the tool, or you can alternatively use a shortcut. So once you launch the tool, let's just go ahead and open it up. You'll be presented with a user interface that will give you a quick overview of the whole shows, or all the shows that you're currently working on. Here I can see the list of my shows that are currently active. I can also see the sequences that are related to each of the shows. I can see the list of the shots in each sequence. And then I can pick and choose the type of template I would like to use for compositing when new shots are created. So let's say I would like to open up shot 10 for Blues Crab's show in our animation pipeline. All I have to do is just hit the load latest work in progress, and it will open up the latest version, version 69 for shot 10 with one click of a button. So I don't have to hunt for any locations or places where I may have saved the scripts. Another thing that we wanted to automate in our animation pipeline are how the scripts are created, what templates are used, where the renders are saved, and the overall versioning system. So let's say I would like to use our little animation pipeline tool to create a new shot. All I have to do is press the work in progress for a shot that doesn't exist yet, and this one already does. So let's find one that doesn't, for example, 240. And I'll hit new work in progress. It will load up a shader rebuild template that was designed by our compositing artists into the clean empty comp. It will save it as a new version 1, and also it will create a writer node with a specific, maintaining the specific naming convention, so all the files will go into the proper directory with the proper names and their proper versions. So as the artist progresses through the shot and keeps on modifying the template, every time he feels like there is a time to save, you just need to save a new work in progress. That will count up the number of work in progresses. Also, it will increase the version number of the shot itself, and the same change will be reflected on the version of the files to be rendered. So let's just do it a few more times, and you can see this keeps on syncing across all the properties here. We also wanted to include the ability to quickly go into the shot folders by pressing the Open Shot Folder button. That will take you into the directory where the shot resides, where the work in progresses are, also the renders potentially. And you can see here I already have 5 versions created. And if I create a new work in progress, that will quickly add a new one into the folder. This way you can easily load up the older versions and then save them as new work in progress easily, if you need to revert back to the previous state of the compositing of each particular shot. Another goal that we wanted to accomplish with our tool that will manage the pipeline is a way to manage the length of the shot as the edit potentially keeps on changing. For this you can use, for example, database, spreadsheet, many other approaches, but we decided to use Nuke Studio. We chose Nuke Studio for its ability to manage complex animation projects all through a nice visual interface rather than just punching data into a database. So here we have an edit for our sequence 1 of blue scraps. Everything is laid out on the main track. You can have as many tracks as you would like. I can easily change the length duration of the shot, and we have currently 16 shots on our timeline. Our tool can then look at the resulting project file that is defined on per show basis. So we here have the rocks from the blue scraps, and it can read the durations and positions on the main track for each sequence. So as the track keeps on changing, our shots durations keeps on adjusting, and we can compensate for the editorial changes quickly and effortlessly. We also wanted to add a functionality or the ability for the compositors to continue and progress through their shots by versioning up as many times as they need to, but only one shot will be considered a master. At the end of each day we keep every single version, but there will be only one master that will be at the end of the day picked up by the render farm and rendered out all together with the surrounding shots. Any version can become a master. All you need to do is just press the Publish Master button, and Nuke will go ahead, version up, override the previous master, and keep the previous version as a backup. Then I can go to Open Folder, and then you will see I have my master shot or the renderable one, and the rest of the work in progress is still saved. We also wanted to simplify the collection of elements that should be used within the pipeline, so we have the ability to selectively load individual pieces of the comp that will be used to assemble the shot, and also you will be able to load pre-rendered elements if applicable on per shot basis. The last bit that we added to the pipeline manager is the ability to load the output of the master, so we can compare it towards the version that we are currently working on. We can load up a proxy resolution, the storyboard for this particular shot, and the animatic for this particular shot if needed. So we have done this to create a solid base to save us quite a few clicks throughout the duration of the project. I would consider our little manager to be an initial stage of gaining some efficiencies. Hopefully this gives you an overview and a few ideas how Python and Qt can be used to enhance and streamline some processes inside of your animation pipeline.
Thanks, Martin. That's a great example of the strength of automation inside of Nuke. Now let's talk to Jesse, where we can build off of what Martin showed us and have a look at live groups. So using live groups extensively allows you to share the workload across the entire team easily, manage the versions of individual components that will come together at a later time, and also build and maintain custom tools that can be shared in your production, allowing a consistent collaborative workflow in your animation pipeline. So embracing this functionality of live groups will fine-tune the process. So let's go ahead and hand it over to Jesse.
Hi, I'm going to take you through how we use live groups and our episonic animation workflow. But first, a quick introduction on what a live group is. So you can use live groups to create compositing templates that can be shared throughout the studio. This will help artists get up to speed and focus on the compositing rather than the setup. We chose to use them in our episodic animation workflow because they allow artists to collaboratively work on the same shot, but in multiple Nuke scripts without the need to render to see the updates. They also let us expose knobs from inside the group to the node itself, which means when viewing the live group or even the tool that we create using them, you'll still have control on those knobs. There are two nodes that we use with the live group itself and the live input. So for more information on live groups, you can go to our learn.foundry site, and under the live group section, we have all the information about what a live group is, how using it with the live input lets artists collaboratively work together, the different inputs and controls, and when we click on using the live group node, you can see this functionality comparison table that shows you the differences between the group in a gizmo, a pre-comp node, and the live group itself. Now that we've had a quick introduction on what a live group is, let's jump into Nuke and actually make one. So here we are back in Nuke, and I'm just going to delete these. We are wanting to create a tool that can be shared throughout the studio. That's going to be the overall shot treatment for all the shots that are being worked on. I'm going to create a few nodes, so let's start with a hue shift, a grade, and a glow. So for this tool, I'm going to use these three nodes, but you could build up your tool with as many nodes as you need. To create a live group, we select the nodes that we want to add into it, and then hit Tab and type in live group. Now those nodes have been added to the live group. We have a new live group node in our node graph, a new tab that has appeared. When we click on that, we've got our live input, the three nodes that I had selected, and an output. What's great with these live groups is that when we expose the knobs while we're creating the tool, we'll still be able to view those exposed knobs. If I float my live group, so we have a little live group here, and then we can enable edit mode. If I double click on one of my nodes, so let's do the hue shift, and let's say that on the live group we want control over the brightness, hue rotation, and the saturation along the axis. So I'll select those and then drag and drop them onto our live group. So there's a new user tab. I'll name this treatment. And then let's say that I want a few knobs from the other nodes. So I'll just double click on the grade, drag the multiply across, and then the glow. And I'll drag the size across. So once we have all of the knobs that we want exposed, I'll disable edit mode, close all the properties in the properties panel, and then dock this live group back in there. Back on the node graph, we can see we've got our live group, and then if I click on our live group tab, at the moment this hasn't been published, so it's not in a state that we can share it. We're going to need to publish this. We click the publish button, then click on our file browser, and when that opens, set the path and the name of our file. So I'm just going to overwrite this one I have here. Make sure we've got a version number and .nk. Then we click open and OK. So now our live group's been published. The file path has now been added to the live group. And if we have a look at that, we've now got the overall treatment Nuke script in our folder. Now that we have this tool and it's published and ready to be shared, let's open a shot that is currently being worked on and load it in. So what I'll do is I'll jump to the Nuke file. What's pretty cool is this script was created by using a live group. So if we have a quick look at this, what we have is we have the background elements. Then we have our midground props, with their passes being shuffled back in. Then we have our foreground elements, the crabs, again with their passes coming in. Then we have the atmosphere, the effects, and then the shot treatment, which we can see is actually driven by a live group as well. If I double click on our shot treatment, we can see we've got our file path. And what's pretty cool with live groups is we can see the updates that are coming through this without needing to render. So if I hit Alt and up arrow key, we've got version 2 and version 3. So we can quickly compare between the different treatments that could be applied to the shot. And then we have the output. So like when we created our tool, the output was added at the end of the nodes. To add a live group into the script, all we need to do is, like with any other node, hit tab and type in live group. We've got an empty live group here, and I'll just drag and drop that into our main pipeline. To load the live group in, all we need to do is hit the folder icon and then click on the treatment. So I created this one a little earlier. Click open, and you can see the viewer has updated. We have a treatment tab like the one that we created, but we've got a few more knobs that were exposed and some titles added to it. So now that we have the overall treatment added in, we can take live groups one step further by using these live groups as a way to create a master script, whether you're the artist or the supervisor, to have an overview of all of the different shots that are currently being worked on. So here we have the master script. I have 3 live groups. These are all then plugged into a contact sheet node, which is why we can see the 3 shots in the viewer. Instead of updating one live group in its properties, if we select all of them in the node graph, we can hit Alt and the up and down arrow keys to update the versions of all of the selected live groups. Let's focus on one of the shots. So I'm going to have a look at this shot here. Let's hit 1 on our live group so we can view that in the viewer. So I'll double click on our live group and we've got it here in the properties. We've got our setup tab, our treatment tab. Then we have our crab tab. In this tab, we have some exposed knobs that are related to the different passes on the crab. So let's say that we're working through our shots and we decide that we want to make a slight change to this crab. We want to give it a bit of a lighter, more yellow light to it. Let's say this is the look that we want for the crab. What's great with using these exposed knobs is that we aren't actually affecting the internal script that this live group is pointing to. So if I come back to our live group tab and change the version, so we're now at version 3, you can see that change has been carried across all of the different versions. I'm just going to go back to version 4. We've made the change, but we don't want it to be carried across all the different updated versions of the shot. What we can do is make this an editable live group, right click and apply the override values to the live group, and then publish that as a new version. So version 5. Now if I version down, we have version 4 that doesn't have the treatment to it, and version 5. As an artist using this master script, you still have complete control of the comp that the live group is pointing to. So if we open up this live group hitting Control Enter, looking at this script, we can see it's got the same setup as the other shot that we were working on has. And if we just come in and focus on one of these areas, so let's say these passes here with the crate. So I'm going to double click on the grade, but you can see that all of the knobs are grayed out. So this is because this is published. So on the live group, we hit Make Editable, and then we can go in and make some changes. So let's say we want the crate to be more of a purple tint to it. So this is how we want our crate to look. All we need to do now is hit Publish and save it as a new version. So we'll click OK, and you can see those knobs have now grayed out on the grade. Now we jump back to the main node graph. If we have a look at our live group, we can version it down, and we can see version 5 is without that purple tint, and we have version 6. So now when we have a look at our contact sheet node again, we can compare the changes we've done to this crab in the shot to the other two that are currently being worked on.
Thanks for that, Jesse. Some nice details on the live group workflow. So now let's go ahead and move on to our next section. As we move further in production, Nuke's animation toolset and workflows are going to allow themselves to smoothly integrate into your production. Since Nuke has all the core features you can find in your animation package, it lends itself well in the polishing of the results and the fine-tuning of shots, all with familiar workflows. DJ is going to walk us through some revisions that are required for a shot and go over these core animation features available in Nuke.
In this segment, we'll talk about some of the benefits of utilizing the curve editor and dope sheet in Nuke. Here we have the script of a shot that has already had the first version of it reviewed, and now it has come back with some notes on it. Before we begin addressing any notes, let's walk through the script to get a sense of what is going on in the script. First, let's play the render to see what we're working with. Starting at the top, we have our source plate. Just by looking at the read node, these color bars at the bottom of the node tell me there are more than the standard RGBA layers contained in this source. So let's see what other information we have to work with. Going to the top left of the viewer, we can click on the layer drop-down menu and see what other layers there are. In this plate, an alpha layer, a depth layer, and 2 matte layers. I'm referring to these as layers because each of them can contain additional channels. When working with CG elements or CG animations such as this, it's highly beneficial to include all relevant and maybe even some irrelevant utility passes or AOVs from the 3D department in a single multi-channel EXR. If the 3D department includes these extra channels, then Nuke can save a lot of round trip and 3D re-render time because these extra channels allow the compositor to leverage that 3D information inside of Nuke. So if we take a look at the next node in the tree, we can already see that the matte channels are being put to use, as we are combining the red matte and the green matte channels to create a new alpha channel that didn't exist before. The new alpha channel becomes relevant when we view through the InPaint node. We can see the crab alpha was used to inpaint the information behind the crab for a clean plate of the background seaweed. The clean plate may not look ideal as it is, but we're going to be able to get away with it because it's an organic element and it'll be defocused. Again, another situation where we were able to save time doing the work in Nuke rather than sending a request to the 3D department to render a separate seaweed plate. Now that we have our background seaweed plate, we're going to put it on a card because we want to put this shot in 3D space. Putting the shot in 3D space is going to allow us more flexibility when it comes to adding in additional elements, or when working with actual camera information from the 3D department. Through a simple projection setup in Nuke's 3D space, we will be able to place these plates of seagrass. We can even add effects in Nuke to make the seagrass appear to move. In this example, an iDistort node is being driven by a UV color information generated by a simple noise node with animated values. The foreground seagrass has an additional transform node to give it a little extra sway. Moving on to the crab element, we can see that we're still using the alpha we generated earlier to pre-multiply the crab from the background seaweed. Good thing the 3D department included those extra passes. Now we don't have to ask them to render out a crab element. Last but not least, we have a couple of different renders of animated bubbles we are adding to the environment. Now that we've checked out all the elements we are working with in the script, let's see how it all comes together. If we view through the scene node, we can see how all the elements are laid out in 3D space. Since the elements were placed on a card, we can now move them around to any position we like. For instance, we can take the card of these bubbles, move them so they appear behind the crab. A simple 3D setup such as this in Nuke can save you the hassle of going back and forth with the 3D department and allow quicker turnarounds for revisions. A more in-depth look at the 3D functionality in Nuke will be discussed in the following segment. Now that we're familiar with our script, we can begin to address some of the notes. Because the script is so nicely organized with labeled backdrops, we can easily jump to any of them by pressing the J key and selecting the backdrop that we want to jump to. So let's select the shot node backdrop 04062 version 1. Looking at our first note, the foreground seagrass is swaying too much and we need to reduce the sway by 50%. So let's jump to the foreground seagrass. Take notice of the little red A in the top right corner of the nodes. The A indicates that there are animated values on that particular node. Let's open the Transform Node Properties panel. Here we can see the rotation has been animated. Rather than going to each of these keyframes and reducing the value 50%, we're going to change all of them at once through the curve editor. Before we jump into the curve editor, let's change our workspace to animation. To actually see what the current animation looks like, let's view through the crop node and adjust the viewer gain to see it a little bit better. Below the viewer are the curve editor and dope sheet. I modified the animation workspace by adding the dope sheet next to the curve editor. We can see the actual curve of the animation in the curve editor, as well as the keyframes where those values are keyed in the dope sheet. To reduce the sway by 50%, select the entire curve. Then just below the curve graph, we are going to divide the values of the curve in half by adding a /2 to the equation, or divided by 2 to the equation. You'll see that the values are now 50% of what they originally were. You could also use multiplication by taking the curve and multiplying it by a decimal percentage. Say if we wanted 50%, make it 0.5, then you would get the same results. All of the original values have now been reduced with simple math. Talk about a time saver. In addition to adjusting the curve with math expressions, there are also a number of curve presets to choose from in the contextual right-click menu. Unfortunately, there's not enough time in this segment to go through all of them, but I encourage you to explore them on your own. Should you need to customize the curve, you can do so in a number of ways, such as selecting multiple points and adjusting the transform box around the points. Adjusting the transform box will allow you to compress or expand the animation curve while maintaining the relationship between the selected points. Single point adjustments can be made to the curve by moving the point itself, the point handles, or by creating a new point when pressing Ctrl, Alt, and clicking on the left mouse button. You have complete control over the animation curve. Now let's address the next node on this list. The camera push is a little slow. Have the camera push finish at frame 150 and reverse the direction to pull out starting on the first frame. Let's jump over to the camera and open the properties panel. You'll notice that the camera didn't actually have a backdrop to it, but I was still able to jump to it. That's because anytime you add a backdrop, it's automatically bookmarked. So if you want to be able to jump to specific nodes that don't have backdrops, just go ahead and bookmark those nodes. In the curve editor, values for the camera and for the transform we adjusted previously are being displayed. This is because the curve editor will display any node with animated values that is currently open in the properties panel. To avoid any confusion, let's close the transform node properties. Now we can focus on the translate Z values for the camera. First, let's move the last keyframe from the end to frame 150. This can be done through the curve editor, but let's do it through the dope sheet for more accuracy to ensure the animation curve is not changed in any way. Now let's reverse the animation curve by selecting all the points on the curve, right-clicking, and choosing Predefined and Reverse. The animation curve is now reversed. If you need the animation to start on the first frame, you can either drag the curve to the first frame or input the number of frames you want to move the curve in the dope sheet. Since the reversed animation starts 30 frames in, we would enter 30 in this box, and making sure the keyframes are selected, press the Move button to start the animation where you desire. 2 nodes down, 2 to go. Let's see what else is left to do. Now we have to do something about the bubble density. Let's take a look at those. View the bubbles at the crop nodes, double-clicking each of the bubble read nodes. Other than being able to adjust individual keyframes in the dope sheet, we can also adjust clip properties as well. We can change the frame range of the clip, change the offset of where the clip will be visible, and we can change the starting point of the clip as well. Rather than having all the bubbles visible at once, let's shorten the clip range by dragging from the edges. This way it'll appear as a brief burst of bubbles. We can move the clip to wherever we want the bubbles to be visible, but for now we'll just leave it where it's at. One other thing we need to do before calling this node done is change the drop-down from hold to black, so that way static bubbles won't appear on screen before the clip animation actually starts. Now we can address our final note. For this one, let's view the bottom of our tree. A Z defocus is already in place, but we'll need to adjust the focus of it. The depth information for the Z defocus was already generated for us through the scanline render node, because we are getting our depth information from all of the cards that were placed in ZDepth. Because the crab on the card is just a flat crab, additional depth information for the crab was pulled from the original plate that came from the 3D department. The crab depth was then merged into the scene depth, giving us a much more accurate representation of the depth within the crab layer. Let's go to the first frame. When the ZD Focus Properties window is open, let's move the viewer focal point to the crab's screen left eye. Set a keyframe for this value, then jump to the end of the shot. Because of the camera move, we need to move the focal point to the crab's screen left eye again. And voila, we have addressed all of the notes and we are now ready to send it back in for review. Before we move on to the next segment, I want to show another example of how Nuke can be utilized for animation using live action elements. In this example, we're using live action footage and adding 2D animation over it. Let's take a look at the render of the latest revision. Depending on the style you're going for, the 2D animation can be used for final or as a previs of elements to come. We can use the previs animation to swap out the 2D animation with VFX elements when they become available. Coming up in the next segment, you want to stay tuned because we'll be going over 3D projections and more about the 3D space within inside of Nuke.
Thank you, DJs. There's some great tips for people new to Nuke as well as current Nuke users. So we saw DJ utilize the 3D space there for a bit. So now we're going to explore that further and take you through some 3D workflows. Now, having the same 3D assets in Nuke that were used to create the shot utterly improves the speed of iterations. And it also gives you artistic freedom. You can fine-tune without going to the 3D department, and many effects are quicker and easier to finalize when you can see them surrounded by the fully composited shots. So let's go ahead and take a look. In this section, let's look at how we can utilize Nuke's 3D space to create and add additional elements to our shots. Because Nuke has a full 3D environment, we can use it to supplement tasks without having to go back to the 3D application. The 3D space can really help to assist our day-to-day compositing. We can bring in geometry through a Read Geo node from production, and we can pick and choose what pieces of the geometry we want visible on import. We can opt to import geometry as a parent and child relationship, and then create separate nodes for each of these pieces of geometry. This becomes especially useful if you want to use the geometry as masks for elements in your shot that may not have been rendered out as AOVs. I'm a huge advocate for using the 3D space for these types of tasks. It can really help speed up your workflow. We can always change what was loaded in through the node at a later time, so don't worry about committing and having to step back if you decide to change directions. Now, one interesting thing that we can do to our advantage is bring in locators or nulls that were created in the DCC. Nuke will read these in separately as an access node, and that's going to give us some position information that we can use to our advantage. This locator was constrained to a piece of geometry that was done inside of the 3D scene. This means that we can use this position information, and we're going to add an element that's going to move correctly and match the render. We're also going to need the 3D camera from the scene for this to work out. We don't need to put our element in the exact same spot as the locator in this case, which is going to give us some freedom of movement. And we have a sign that I've modified, and I want to add it and have it be attached to this crab trap that's going to be moving throughout the shot. We can add this to a card node so that our sign is now in 3D space. We can then add a transform geo node and plug the axis node into the axis input of the transform geo. This means wherever that cage goes, our sign is going to travel along with it. We can take it a step further by adding an additional transform geo node right before, and let's offset the pivot. Now we can add additional animation of the rotation to the sign. We can go through and set some keyframes, and now we've added a second layer of animation. Let's look through the scanline render. We can adjust the sampling and motion blur attributes, and we can tweak anything else that we need for the output. And then we'll do some color correction to integrate it into our shot. The great thing about this is that we have the ability to modify the look of the sign on the fly. We can also tweak the position of the sign. We can alter the look while getting feedback right away. We can add more elements because we have the animation information from the axis. Let's add some bubbles to the other side of the cage.
We've selectively loaded some of the geometry for the cage, so we can add a fill mat node and plug it into the geometry. Now it's being used as a mask for our bubbles, and the bubbles can now be both in front and behind the cage. We can swap the element out, maybe for some kelp that has been growing in the cage over time. But we really have the flexibility to add additional elements to our 3D animation directly inside of Nuke. Another thing we can do is add additional light passes by relighting our shot. Now this becomes extremely useful for saving time and tweaking the shot with real-time feedback. We're going to need a relight node and a position to points node to drive this setup. Let's first look at the position to points. Now we need normals and a position pass to utilize this. So this can be derived from the render passes that were outputted, and that can be a standard part of your AOV setup for your project. We want a position pass for the geometry's XYZ information and a normal pass for the lighting and shading information that we want to apply. We're going to also need a color pass, but this can be arbitrary as we only want to pull out some additional light hits. Now we have a unique situation here. We don't have those passes, but it's okay because we can create them inside of Nuke. We need our geometry and our camera for the shot imported into the scene, which will allow us to create these passes. In our scanline render, we want to output vectors. For our surface point, we want position, so we can create a new channel and call it position. We want 3D information, so we're going to add X, Y, Z to the channels. Now our surface point is linked to it, and we have a new channel called position. We want to do the same thing for our surface normal, so we're going to make a new channel, call it normals. We also want the X, Y, Z information. So now we're outputting this information throughout our comp. We can shuffle out these passes from the X, Y, Z to RGB. And now we have them ready for our position to points node. Again, if we have these passes from our render, we don't have to do this step. We can plug in our color information to the node, our positions, and then our normals. We now have the information the camera sees in our 3D viewer via the points, so we can start to relight. Let's create a light, and we can use any type of light for this. We'll use a point light and put it into a rough position. So now we can use our relight node. The relight node wants color, which will be the output from our render, lights, which we've just set up, a camera, which is the imported camera from the scene, and a material. So we're going to tell the node what the normal and the position pass is called. Now for the material slot, we can use different shaders in here. Now in this case, we want to use a specular shader, so we're going to use specular. And we'll plug it in, and then now we have a result. So we can go ahead and tweak the light position and get instantaneous feedback. We can adjust the material properties as well until we have something that we like. After this, we can plus the result on top of a render, and just like that, we've added additional lighting to the shot directly from Nuke. Because we've done it this way, we get a real light hit that will follow the curvature of the geometry and won't have that fake look. If you're new to this process, you can select Tool Sets, go under the 3D section, and check out the Relight toolset to get started on it. Nuke can bring in UDIM textures for your model, which will allow you to make modifications to the texture that has a texture setup that goes beyond the one-to-one texture layout. You can create a UDIM import node and point to a set of textures. You have some options that you can use, and then you want to hit OK. You'll get a setup complete with frame holds, UV tiles, and merge material nodes. You also get this multi-texture node, which optimizes the merge mats. Now that we have access to the texture information, we can add additional texture to the model. I have this slime texture and I want some slime to drip off the crab's head. I've added some effects to the image to give it some movement using the iDistort node and a transform node. I'm going to use this to place it on top of the crab's head. Because I have texture information and the model uses UDIMs, I can pinpoint exactly where I want to place it. Once I've done that, I want to disable the original texture as I don't need it and I get feedback on the position. As soon as I have it roughed out, I can animate a roto shape over time to give it the appearance of slime dripping down. The sky's the limit with this approach. We can be adding additional noise, putting stock footage on top of this, animate attributes on any of the nodes that make up our effect, and we're not going to have to worry about where to position things, and we're going to use the UDIM importer to make this happen. This becomes a really handy approach when we're adding additional effects to our shots. Let's look at how we can utilize Nuke's 3D space to project images onto geometry, which can give us additional effects on top of our render. I have an image sequence of caustics, and I want to project this onto our 3D model for the shot to add a little bit of additional lighting. I've imported the geometry as well as the camera. I'm going to duplicate the camera and delete the animation on it at a frame where I feel it provides a good visual coverage of the model. This is going to be our projection camera. We can create a project 3D node and plug in our texture and our projection camera into this node. So the project 3D will be plugged into our geometry for the model and then fed into a scene node. From here, we use a scanline render to render our pass, and this can be plussed or screened on top of our render. We now have our caustics sticking to the model and scaling correctly to match the camera's movement. We can be using these projections in many ways. We can project a render of a set environment onto the geometry of the set, and then we can use that as a background inside of Nuke. It's quite a flexible approach, and we're looking at just one of the ways that we can utilize this for our animation production to help to add to our render.
So that about wraps it up. I hope you enjoyed what you saw, and thank you for watching.
Okay, hello everyone. This is Martin speaking. So hope you liked it. Hope you liked what you saw, and if there are any questions, we are more than happy to answer them. I saw one from Mael. So the question was, can you snap and constrain access to a vertex? As I think Terry answered, you can snap, but you cannot constrain directly. What you can do though, you can use a Python node, Python GeoNode, that will allow you to read the vertex position, and then you can feed that position to axis, any axis, and that will make like automated connection between those two. It will move together.
I see one there, Martin. Any way to get shadow casting via the relighting method? And yeah, you can. Your position to points node has a toggle on to cast and or receive shadows. So you would do it that way. And the sample scripts, Martin, as well?
Sorry?
I'll just read it out. It says, will the sample crab scripts be available for review? Unfortunately, we can't. They were shared by Ari Rubenstein, but just to share at Foundry and show, but we can't distribute
them. The Python script, well, the snippet I can, yeah, well, we can post it. We can definitely post the links to the example that they can show you how to make the constraints. Or constraints, how we can read the positions and then bake them potentially into animation curves.
Yeah, so just talking about that topic for a second, I mean, it's when you have an Alembic file that has multiple geometry inside of it, that X, Y, Z value isn't exposed to Nuke's UI. So what Martin's suggestion is a great way to approach, or if you have access to the scene in the 3D application, using dummy geometry in place, parent constraining a locator or parent constraining some piece of geometry inside of their locator, preferably, or any type of null. That way you get the access node directly inside of Nuke, which is helpful.
Then there was another question from Chris Blake. Are you using localization in your pipelines? Personally, I'm advising everyone to use it. It's a great feature, especially when you're working off of any file server where you might be fighting for bandwidth with the other artists around you. It's a great way to non-destructively use your fastest hard drive to feed Nuke with data. So yes, on my end.
And TT has a question. Since you already have the Alembic Geo, why not just do the relight in 3D / scanliner rather than round tripping back to 2D and the relight node? So this is possible, but depends on your geometry. So why people opt to use the relight node is because when you have extremely dense geometry, your scanline render is going to take longer. Working with the application in 3D space is going to be much heavier. So when we're talking about a model that has maybe 30, 40,000 polygons, sure. When you start getting into the millions of polygons, the relight method is the way to do it, especially if you have multiple pieces of geometry in there.
There was a question in the chat from Perry. So the question was, what are the best options for VDB rendering inside of Nuke if you want to bring a render previously simulated VDBs from Houdini? So currently, you have really only the options would be a third-party solutions like Eddie for rendering only. You can simulate it as well. Or you can use, for example, Octane, V-Ray to render VDBs. But stay tuned for this. That's
very mysterious, Mark.
Yes. Okay. So I'm not sure who wants to take this. So how do you match the motion blur from scanline renderer to motion blur from lighting?
I mean, if you want to get exact matching when your 3D pass is rendered out, if you request, or depending on how you guys are working, but if you're asking for additional AOVs as a compositor, usually communicating with the lighting department on what type of AOVs that you need, you would want a motion vector pass, and then you can use Nuke's vector blur. From there are presets for different renders inside of there, or you can just tweak manually as well with the attributes on there to get the exact match. And that way you're getting the true motion blur from the image. So then for scanline, what you would do if you're rendering it inside of Nuke, you would pass on motion vector data. So you would want to enable it inside of the scanline render and then put that into a vector blur instead of using scanline's motion blur. I think there's another one where there'll be any skill up sessions for Blink scripts. I don't think we'll be able to answer that one. I would probably maybe Joyce could answer that or put in a request and then see if that comes in.
Something popped up. Thank you.
Okay, I think that might be it.
Good. Any more questions, guys? We'll be around here for a minute or two if there is nothing else. And USD in Nuke. Yes. Was it 12.2 to 10.3?
12.2, the latest version of Nuke. The ReGeo also ingests USD, and that's phase 1 of the USD input.
Yes.
So there are quite a few functions functioning with USD already. And then the team that is working on that particular project is expanding on it for the next iteration. So it's really just talking about studios and what they want to pull out of USD into Nuke. So that keeps on evolving. But yeah, as of 12.2, you can have USD. So Noah's asking when the newest version of Nuke is expected to drop. So that is, we're at Nuke 12.2. That's going to wrap up the Nuke 12 series. So Nuke 13 is slated for the first quarter in 2021. That'll be exciting with Python 3 in there.
Mm-hmm.
So what kind of geometry are we using in this? So it was Alembic files. So the package that Ari created in was Maya and then exported out of Alembic into Nuke.
Emile, the Eddy is not standard in Nuke. I was just giving you suggestions of what currently can be used to render VDBs directly inside of Nuke as via plugins, third parties.
So any improvements, performance to unnecessary expressions, nodes, processing. So be sure to check. This was added in a previous version of Nuke in your preferences to turn on lazy expressions for those expressions that aren't currently contributing to the scene. So maybe people are unaware of it, but you should try checking it, turning it on, and seeing if that helps. Hi guys, there's a way to invert the UV map render for stabilize. I'm not sure about that, Martin. I don't know if you have maybe using STMap as a bridge.
I'm not entirely sure what you would want to achieve. I mean, a lot of these things can be done through the expression node. Any kind of pixel math operations can be done through that, but I guess, need to know a little more to help.
Okay, so there is one by Josh. I don't know if we answered that one. Great presentation. What is the benefit of rendering the background separately if it's occluded by the character? So for that, maybe we're referring to DJ's example where there was a hole in the background, a layer, and quite honestly, DJ had a bit of a bind there because what was provided to us from that project was the entire render on one pass. So DJ needed to separate it. So he used the alpha, like he separated the foreground character from the foliage that was behind, and he was left with the hole. So normally, if it was rendered in foreground, midground, background passes, you wouldn't have that issue. So I think, it was a very interesting webinar, hopefully, because it was 4 very different angles on how you can utilize different things that might not be in your pipeline. So I think we covered a pretty good variety, hopefully.
Okay. Okay. I'm not entirely, but Mark has a question whether you can get vertex colors out to Alembic Geo onto the skin line. That would require a little more research on my part, so I'm not off the top of my head. I don't know.
I haven't seen that happen.
Great. Do we have any more questions out there? Well, thank you very much for coming. And I guess have a great morning, evening, afternoon, whatever, wherever you are.